In this video, we're going to look at more examples of integration by parts. Here we have integral 0 to pi over 2 x sine x dx. And the question is, how do we choose u and how do we choose dv? We're going to apply the light principle like we have been for the past two videos. Choose u to be the function that comes first on the list. So L stands for logs like ln x. I stands for inverse trig functions like tan minus 1x or sine minus 1x. A stands for algebraic functions, in this case is x. T stands for trig functions, in this case that would be sine x. And E stands for exponential functions like 2 to the x or 3 to the x. So clearly the algebraic function comes before trig function, so we're going to let u be equal to x. So u is equal to x. Its derivative du is equal to dx. dv will be whatever is left over, that's sine x dx. So it's important to realize that once you choose u, then the remainder, whatever is left over, would have to be dv. Now let's integrate dv from both sides. So integrate, and we get v is equal to integral sine x is negative cos x. Alright, so what we have is integral 0 to pi over 2 x sine x dx, and our choice for u is equal to x. Its derivative du is equal to dx. dv, that's equal to sine x dx. And integrate both sides, and we get v is equal to, so integral dv and integral sine x is negative cos x. So now we apply the formula, integral from 0 to pi over 2 x sine x dx. That's equal to u times v, that's going to be x times v, which is minus cos x, minus integral v, which is minus cos x, times du, that is dx. Let's label everything. So u is equal to x, this is u, sine x dx, this part of the integrand is dv, and the result is u times v, this is u, times v, minus integral v, v is minus cos x, and du is dx. Alright, so what we get is, and let's also put the limits of integration, that's very important, from 0 to pi over 2, because this is a definite integral, we need those limits of integration, and 0 to pi over 2. Alright, so we have 0 to pi over 2, x sine x dx, that's equal to minus x cos x, from 0 to pi over 2, plus integral cos x dx, from 0 to pi over 2. So we get minus x cos x from 0 to pi over 2, and antiderivative of cos x, the integral of cos x is just sine x evaluated from 0 to pi over 2. So what we have is integral from 0 to pi over 2 x sine x dx is equal to minus x cos x plus sine x, evaluated from 0 to pi over 2. Alright, so now let's plug in the upper limit and the lower limit in. We get minus pi over 2 cosine pi over 2 plus sine of pi over 2 minus, plug in the lower limit in, we get minus 0 cos 0 plus sine 0. Now cos of pi over 2, that is just 0. Sine of pi over 2 is 1. Cos of 0 is 1, sine of 0 is 0. So we have to memorize those results. So we get the integral from 0 to pi over 2 x sine x dx, that's equal to minus pi over 2 times 0, that's going to give us 0, plus 1 minus, and that's going to give us 0 times 1, that's going to be 0 plus 0. So the answer is 1. That means the value for the integral is 1. All right, so we can write 0 to pi over 2 x sine x dx. The result of this integral is equal to 1. All right, let's write a few of the trig functions that we looked at earlier. So it's important that you memorize that cosine 0 is equal to 1. Cos of pi over 2 is equal to 0. Sine of 0 is 0. Sine of pi over 2 is equal to 1. Good to memorize these. You will need them. All right, let's look at another question. Here we have integral root x log x dx. So we're going to let u be equal to log x. So u is equal to ln x. The derivative du, that's going to be 1 over x dx. And dv is what is left over. dv will be x to the 1/2 dx. Notice that we're writing root x as equal to x to the 1/2. And integrate dv to get v. So we get v is equal to, reverse the power rule, we get x to the 3/2. Divide by, let me clean this up, you get x to the 3/2. Divide by 3/2, that's 2/3. All right, so now we have u, we have du, we have dv, and we integrate that, and we got v. So let's apply the formula. Integral u dv is equal to uv minus integral v du. So we have integral x to the 1/2 log x dx. That's equal to u times v, that's going to be ln x, times 2/3 x to the 3/2 minus integral v, that's 2/3 x to the 3/2 times du, which is 1 over x dx. All right, let's simplify this. We get 2/3 x to the 3/2 log x minus, bring the 2/3 out, and x to the 3/2 over x to the 1, we can subtract off the exponents, and we get integral x to the 3/2 minus 2 over 2, that is 1/2 dx. All right, so what we have is 2/3 x to the 3/2 log x minus 2/3, and integrate x to the 1/2 using the reverse of the power rule. That's going to be x to the 1/2 plus 1, that's 3/2. Divide by 3/2, that's the same as multiplying by 2/3 plus constant c. All right, so what we have as a result is 2/3 log x times x to the 3/2 minus 4 over 9 x to the 3/2 plus c. Let's write that down. So the result of the integral is 2 over 3 log x times x to the 3/2 minus 4 over 9 x to the 3/2 plus c. Now let's talk a little bit about strategy. Why did we choose u to be equal log x? If you look at the Layard principle, L stands for logs. That's of course log x. And A stands for algebraic function. In this case, that would be root x. And clearly, logs comes before algebraic function. So that means we have to choose u to be equal to ln x. And once u is determined, then you differentiate that. You get du is 1 over x dx. And once you determine u, then it's very easy to find dv, because whatever is left over. In this case, dv is equal to x to the 1/2 dx, and we integrate that to get v. So v would be x to the 3/2 divided by 3/2. That's the same as multiplying by 2/3. So that's just going over the strategy of how we chose u to be equal log x. And the reason why we did that was basically following the Layard principle. All right, thanks.